This is example number 3 on mesh analysis. In this example, it says using mesh analysis, find the current Ix and Vx. So the question is asking for the current that goes in this resistor and the voltage across this resistor. So we have to solve this first using mesh analysis, and then once we are finished, we can use these currents to find Ix. Let's see how we will do that. So for loop 1, I will write the KVL equation for loop 1. So plus 15 minus I minus 1 times I1 minus 2 times I1 minus I2. We start with I1 because we are in loop 1. That is the first equation. We arrange this equation. We arrange the equation, and that's it. We go to the second loop. So we go for loop 2, we will start here. We have I2 here. We have I2. So minus 3 I2. The voltage across here will be minus 3. As I said before, we always use minus sign for resistor. This will simplify our work. So minus 3 I1. And for this one, we will say minus 4 I2. And then when we come here, we will say minus 2. We will start with I2 because we are in loop 2. I2 minus I1 equal to 0 because I don't have any voltage source here. We arrange the equation 2, 9. This is equation 2. Now I have a system of two equations. And I need to solve both of them. I need to solve to find I2 and I1. So in this system, if I add together, I will not cancel any one of them. I will not cancel I1 and I will not cancel I2 as in the previous example. So I have to change one of them. I have to change one of the currents. I have to change this 2. I have to change it to make it equal to 3. So in order for me to change this 2 and make it equal to 3, I have to multiply it. I have to divide by 2 and then multiply by 3. So if I divide by 2, this will become 1. And then I multiply by 3. So I will multiply the whole equation by 3 over 2. So the new system of equation will be like this. So the first equation, no change. The second equation, we will multiply by 3 over 2. And we will multiply here also by 3 over 2. And we will multiply also here, but this is 0, so no need. Now, what will happen after I multiply? This will become equal to 3. This 2 will become 3. And this will become 27 over 2, 9 times 3, which is 13.5. Now, if I add the two equations, I will cancel this. This one will be cancelled. And here I have 2, and here I have minus 13, so I have minus 11.5 equal minus 15. This implies that I2 is equal 1.3. Then I need to substitute. I need to find I1 now. I will need to substitute in this equation. So I just wrote the equation again just to make it simple. I will substitute I2 with 1.3. So 9 times 1.3. 2I minus 9 times 1.3 give me 0. Then solve and I will get 5.85 milliampere. So now I got the two currents. I got the current in the first loop and I got the current in the second loop, but I didn't get the current in this resistance. So it means I have to use these values to find the current that goes into this resistance. Now, what I'm doing here, I'm writing the values of the current. This is I1 is 5.85. That is the current that goes in this loop. And 1.3, that is the current that goes into this loop. So what will be the current in the middle? What will be the current in the middle? The current, this current Ix is going down. As you can see, it is going down. It is the same as the direction of I1. I1 and Ix are having the same. So Ix will be this current minus the other current. So Ix will be this current 5.85 minus 1.3, which will be 4.55 milliampere. That is the current that goes here. And the voltage is very simply, we multiply the current by the resistance, which is 2 kilo ohm, we get the voltage.